Okay, now welcome to Apostle 1 tutorial. This is Apostle from Infantile School, yes. And I welcome you to the Apostle 1 tutorial. This one just will help you have a strong foundation in mathematics. Yeah. Now, in our previous video, I talked about indices. And then if you watch, you'll be able to understand everything indices. Now, at this point, I'm going to tackle the logarithm. So indices and logarithm, they go hand in hand, yes. Anything that is related to indices, you can transform it to or translate it to a logarithm, yes. So let's look at this particular thing. Now, from indices, we talk about the fact that we can express a number in the form of an index form or exponential form. Example, if I have 32, this 32 can be expressed in the form of index form. That is a number that can multiply itself to get 32, but the number multiply itself. So if I have 2 can multiply itself 5 times to get 32. If I have a number like 8, 2 can multiply itself how many times to get 8? 2 can multiply itself 3 times. So this one is the number and 8 inverse, the number and 8 index form or exponential form. Now, in the introduction of logarithm, you can express this one in the form of logarithm. Look at it very carefully, because in some objective tests they will ask you to express this one in the form of log. So let's look at how we can express the form of log. Now, if I'm expressing the form of log, logarithm, the simple form of logarithm is log. We use the first letters to represent logarithm. So we have logarithm of a number, logarithm or log of a number. Now, log of a number, which is log has a particular number, we will write the number here. So if you're talking about log of 3, it will be log 3. That is how we pronounce it. This one is called log 3. Now, since indices has a number, a base, and an exponent, the log also has a base. And where do we write the base? We write the base here, down here. You write the base down here. So example, if the base, log of a number, the number is 3. The number is 3. To a base. To a base of 2. It means that the base of this logarithm is supposed to be 2. So I'm going to have the base of 2. This is how we write it. So how do you pronounce this one? Is log 3 base 2. This one is log 3 base what? 2. Now sometimes we write a number here. And this number is not really necessary though, but I call it the coefficient of the log. So if here is 4, then it means that we have 4 log 3 base 2. 4 log 3 base what? Base 2. 4 log 3 base 2, don't forget. Now this 4 log 3 base 2 can be written in so many ways. If I have 4 log 3 base 2, or I can also write something like this. 2 log x base y. 2 log x base y. Now this one means that I have log x base y 2 times. It means I have log x base y plus another log x base y. I have 2 of the log x base y. Now this one means I have log 3 base 2 4 times. So it is like log 3 base 2 plus another log 3 base 2 plus another log 3 base 2 plus the last one log 3 base 2. So when we add the whole of this one, we are going to get 4 of the log 3 base 2. That is why I said we represent this one. This one is the coefficient of the log. So here is 1, 1, 1, and then 1. 1 plus 1 plus 1 plus 1 is giving us what? 4. The same I apply to this one. Here is 1, here is 1. That's the coefficient of the log s base y. So when you add this, and you're going to get what? 2 of the log s what is y. So I call this one as the coefficient. Yes. So every log has a base. Every log has a base. Yes. Now, As time goes on, I will explain this one very well. So when you see LOG, when you see this one, that's a short form of logarithm. A short form of logarithm. Now, so let's see. Let's see. Now, we can express this one in the form of log by the definition of logarithm. If I talk about the definition of logarithm, that is what I'm going to talk about. Now, if I want to express this one in the form of logarithm, look at it very carefully. Express this one in the form of this one is 32 is equal to what? 2 exponent 5. Now, this one means that the base 2 is erasing the 5. It is carrying the 5. Use the base 2 to erase the 5. So if I want to write this one in the form of logarithm, it is the same as log of the 32. Log of the 32 having a base of what? Base of 2. The base of 2 is giving us an answer 5. So this is how we can write this is how we can write this one in the form of log. Look at it very carefully. So I can translate from here to here and then from here to here. All of them works. And this one is by the definition of logarithm. Now let's look at this one. Let's look at this one too. Expressing this one in the form of logarithm. So what is the base? The base here is 2. I told you that when we are dealing with logarithm, we have the log here and the base is here. This side is the coefficient, but we don't normally talk about the coefficient. So let's see. Now this one means that 8 is giving us 2 exponent 3. The 2 is the base, the exponent of is what? 3. It means that log of the number a to the base what? 2 will give us the exponent 3. So the exponent is usually the answer of the log of the 8. So the log of the number 8 to the base here is 2, will give us what? 3. It is just as simple as that. It is just as simple as that. So let's look at this one too. So if I have 25 can be expressed as index form, which is 5 exponent 2. And this one can be expressed in the form of logarithm. How are you going to express this one in the form of logarithm? It means log of the number 25. Log of the number 25 to the base 5 will give us 2. Log of the number 25 to the base 5 will give us what? It will give us 2. So this is very simple. This one is very, very simple. Now let me talk about the last one. Let me talk about what again? Let me talk about 16. Now 16 can be expressed as 2 exponent 4 in the form of an index. So this one means that we are going to have log of the number 16, log of the number 16 to the base 2 will give us an answer 4. And this one is called the definition of logarithm. Definition of logarithm. So let me define logarithm here. So we can translate from here to here and from logarithm to indices. And this one forms a crucial part of logarithm. So this is how we can just translate. So by the definition of logarithm, by the definition of logarithm, so I will say that logarithm of any given number, or quantity, logarithm of any given number. So which means I have to use a number to represent any given number. The given number is 32, is 8, is 25, is 16. So logarithm of any even number, let's say m, to a given base. So a given base. Now this one I'm talking about the base. Now let me use a variable a to represent the base. So logarithm of any number m to a base a. Now this one can be expressed as, or it can be written as, so can be written as log of m to the base a. This one can be written as log of m to the base what? A. So the quantity is m, or the given number is m. Given to a particular base, the base is what? A. So this one is the log m base what? A. Now, what will be the answer to this one? This one means that if you want to get the given number m, we need to use the base a to raise a certain number. We used to use the number a to raise a certain number. So this one is what? Is the base. Okay, so let me say is the number is the base can be raised to give the given number. The given number. Now, so when you talk about the logarithm of this one, is the number the base can be raised. Now, the number the base can be raised, let me use n to represent the number. Is the number the base can be what? Can be raised. Meaning the base will come and raise a certain number to give you the given number. Now, what's the given number? The given number is m. The given number is m. So this one is so simple. It means that if you have log of m base a, now that is log of m base a is the given number, meaning it is equal to the given number n. That can be raised. So this is what we do. So it means that the base will come and raise the given number. The base will come and raise the given number, which means that it's going to have a exponent n. To give the given number, the given number is m. So that is about translating from logarithm into an indices form. So this is actually the definition of the logarithm. That is why we said that if we have m in the form of an index form, so m is equal to a exponent n. M is equal to a exponent m. Now this one in the form of logarithm, it means I'm going to have the log of m to the base. What is the base? The base is a, to give us the exponent n. This one means that this given number m is equal to a number to which the base can be raised, which means the base will come and raise this particular number, that is a exponent n. So this is a way of changing from logarithm to indices, and then from indices to what? Logarithm. So for example, this is just by the definition of logarithm. Now, for example, if I have log 32 verse 2 is equal to 5. If I want to write this one in the form of this, you can translate from this one to the form of this. The logarithm of 32 to the base 8. This 32 is the same as the number to which the base will raise, meaning this base will come and raise this number. So which means that the logarithm 32 is equal to this base will come and raise the 5. So 2 exponent 5. That is from here to here. So it's just as simple as that. So if you have a logarithm and you want to find a particular value, use the base to come and raise the 5. And that is just by the definition of what? Logarithm. Now let's look at this small question. Now question 1. Convert the following into logarithm. Now a now if I have 27, which is equal to 3 exponent 3. Now b 64 is equal to a exponent x exponent 4. Now c 10 exponent -1 is equal to 0.1. Now and then d, let me talk about the last one, d. 1 over 64 equal to 4 exponent -3. Now we are going to convert the following into logarithm, which means I have to take this one that we express this in logarithm. After that, we're going to take a logarithm that we express this in what? We find the value of that particular logarithm. Yes. So let's see. Solution. Now, if I have 27 is equal to 3 exponent 3, what does it mean? In the form of logarithm, it means that log of the number 27, log of the number what? 27 to the base 3, you see, to the base 3 will give us the answer, the given answer, which is 3. Very simple. I hope you've not forgotten from here. Okay. Now b, 64 is equal to x exponent 4. So this one means that what? Log of the number 64 to the base. What's the base here? The base is x. So to the base x is equal to what? The exponent will give you the number 4. This is just by the definition of logarithm. Now the next one, let's talk about c. We have 10 exponent -1 is equal to 0.1. Now this one is in the index form, and this one is the number itself. You understand? So which means log of this one will give us to the base. The base is 10. So this one means log of what? Log of 0.1 to the base. Now the base here is 10. Will give us the exponent, which is -1. That's very, very simple like that. Now d, we have 1 over 64 is equal to 4 exponent -3. So number and then its index form. So this one means what? 1 over 64 is equal to 4 exponent -3. What does it mean? It means log of the number 64, log of the number 1 over what? 64 to the base 4. The base is 4. will give us what? Will give us the exponent -3. Now you see that the question is so simple, right? This one is just about the definition of logarithm, expressing this one in the form of logarithm. Yes. Now, we are moving into another way where they will give us a logarithm like this, and we are going to find the 3. Now, I'm going to solve this a different way where they will give us a logarithm of 27 to base 3, and then we are supposed to find the value or the answer. So let's look at this particular question. Now, question number 2. Now, let's look at this. Now, question 2, find the value of the following. Now, the first one, we have log 32 base 2. Now B, we have log 27 base 9. Now C, we have log 0.25 base 2, and then the last one we have log 25 base 5. Now let's see how we can solve this simple question. Solution. Now let me consider the first one, A, that is log 32 base 2. Now, how are you going to solve this one? You know, for the first one, I think we had a particular answer. Now, this one, how are you going to solve? By the definition of logarithm. So, I'm going to say that let the whole of this one be equal to a particular variable, then I'll solve for that particular variable. So, let log 32 base 2 be equal to a particular variable. Let's say m. So I'm going to solve for the value of m, and the answer for m is the same as the answer for log 32 base 2. Now at this particular point, by definition of logarithm, we said that when you have log 32 base 2 is equal to m, then it means that the base is supposed to come and raise the number m. So you're going to get 32 is equal to the base will come and raise the m. So 2 exponent m. 2 exponent m. Now at this point, what I have to do is now at this point we've changed the logarithm to indices. So I have to apply indices approach to solve this particular question. So what I'm going to do is that I'm going to express the 32 in the form of an index 4. Yes, 32 in the form of an index form is the same as 2 exponent 5, which is equal to 2 exponent m. So at this point, since the base are the same, it means the exponents are also the same. So therefore, we're going to get the m to be equal to what? 5. Now what is m? M is log 32 base 2. So I can conclude that log 32 base 2 is equal to m, and m is equal to 5. So this is very simple. Very, very simple. Now let's look at the next one, the B. I'm going to use the same approach to solve this one too. Now we have log 27 base 9. So I'm going to say that let the log of 27 base 9 be equal to a certain variable m. So the next step is that I have to use the base to raise the m from the definition of logarithm. So we're going to have 27 is equal to what? 9 will come and raise the m. So 9 exponent m. Now at this point, I have to make sure that the bases are the same. This one is from logarithm indices, so I have to make sure the bases are the same. Now, how can I make the bases are the same? I can't express this one to get base of 9 unless I convert all of them to base 3. So the 3 is the same as 3 exponent 3. The 9 is the same as 3 exponent 2. So we have 3 exponent 2. The 2 can multiply m like this. Now, since the bases are the same, it means the exponents are also the same. So we're going to have 3 is equal to 2m. Divide both sides by 2. M is equal to 3 out of 2. So therefore, log 27 base 9 is the same as 3 out of 2. You see how it's number like this? Now let's look at the next one. Let's look at the C. Now log 0.25 base 2. So we are going through the same process. Let the log of 0.25 base 2 should be equal to a particular variable m. So at this point I have to use the 2 to raise the m. So I'm going to have 0.25 is equal to 2 exponent m. Now this one is decimal. I have to convert this one to an index form. Now I know 0.25 is the same as 25 divided by 100, which is the same as 1 out of 4. So I can write 1 out of 4 straight away. So 0.5 is the same as 1 out of 4. Now you know this one is now in the form of indices, so I have to apply this approach. Yes. So what I'm going to do, I'm going to convert the 4 to base of 2. So we have 1 over 4. The 4 is the same as 2 exponent 2. Is equals to 2 exponent what? M. Then we apply the inverse rule from here. Now from the inverse rule, 1 over 2 exponent 2 is the same as 2 exponent negative 2. So we have 2 exponent negative 2 is equal to 2 exponent m. Now since the bases are the same, the exponents are also the same, so therefore m is equal to negative 2. Now at this point it means that log of the number 0.25 base 2 is given as m, and m is negative 2. So I can conclude that log 0.25 to the base 2 is equal to negative 2. Now let me solve this last one. You see, this one is very simple. Let's solve that one, then we see what to do. Now we have log of 25 to the base of 5. So I'm going to say that let log 25 to base of 5 be equal to a variable m. So use the base to raise the number. So we have 25 equal to 5 exponent m. Now at this point, I need to convert this one in the form of an index form, which will be 5 exponent 2. So I have 5 exponent 2, which is the same as 25, equal to 5 exponent m. Now at this point, since the base are the same, the exponents are also the same, so we have m to be equal to 2. So therefore, our log 25 to the base 5, the answer is 2. Now I am solving this question based on the definition of logarithm. Now I want to get to some point. I will solve this one a different way, a different method. So for now, let's talk about the definition of logarithm. Now I'm going to solve the last question on this particular method using the same definition of logarithm. Now at this point, I'm going to solve a question in the form of an equation. So example, now question 3, find the value of m in the following. So we have A, now we have log m base 4 equal to 2. Now B,